Hi viewer, I welcome you to Edim TV. It is the station where you watch and learn. I'll be taking you through Mathematics Form 3, lesson number 19. The topic it is Surds. I'm your tutor, Lucy Muthoni. Welcome. Let us first of all look at our lesson goals today. We are going to do the rational and irrational numbers. We look at the sums. Then we look at how we can simplify the sums and how we operate the sums. Let's get started. The first thing you are going to look at, I know you have already mentioned about the natural numbers. We also have the fractions, the perfect squares, the perfect cubes, decimal numbers. We have talked about them, all of them. But there is something that we refer to it as rational and irrational numbers. Rational number is that number which can be written in the form of P divided by Q, where P and Q are integers, and Q is not equal to 0. P and Q should not have any other common factor other than 1. So that is the number we refer to it as rational number. And these numbers are natural numbers, the ones that we talked about, fractions, perfect squares, perfect cubes, decimal numbers, both those that are terminating and those that are recurring. Now we go to the irrational numbers. Now when we talk about the irrational number, they are numbers that cannot be written in the form of P divided by Q. For example, we have pi. Pi cannot be written in the form of P divided by Q. And sand 2, sand 3, square root of 5, 3, sand 10. All those numbers and many others cannot be written in that form. That one gives us the irrational number. That is the reason as to why we come up with the topic of the sums, because there are other numbers that we have not included in the mathematics. And that is when now we start to operating. Sums. Sums are numbers that don't have exact square roots or cube roots. For example, we have the ones that we have there, sand 2, sand 3, 3 sand. Not 3 sand, but the cube root of 36, cube root of 16. So we don't have exact square root. The sums are irrational numbers, while the number in the number under the root sign is a rational number. So you can be able to get that. The product of a sum and a rational number is called a mixed sum, like the ones that you can be able to see them there. 2 sum 3, 4 sum 7, and sum 2, and many others. Now, let us get the order of sums before we go to their operation. For example, we have the ones that we refer to them as order 2. These are the ones that are written in that form. Square root of 2, square root of 3, square root of 6, square root of 10. But the others that we refer to them as under 3, which are cube root of 2, cube root of 6, cube root of 10, cube root of 20. Then under 4 in that manner. That's how we get the order. That is the reason as to why you can see the point there. We said that the nth root of a number is the order of the set. We just get the examples. Now we start simplifying the sums. We have the first example, which is sum 18. It can be written as the factors. We get the factors. One must give us the perfect square root. For example, we have the square root of 9 times 2, which can be written as square root 9 times sand 2, which is 3 sand 2. 72, sand 72, it can be simplified in the form of sand 36 times sand 2, which is 6 sand 2. Then 200, it can be simplified to 10 surd 2. We go to the operation of sums. After simplifying the surd, now we can start operating them. And we are starting the first one, that is addition and subtraction of surds. Surds can only be added and subtracted if at all they are of the same order. And the number under the root is the same. Get that? Only the order must be the same and the number in the root must also be the same. We have the examples there. If at all we have the number outside, we put them in bracket, and then from there we can operate them. Multiplication and division of sums. Sums of the same order can be divided, no matter whether that value that is in the root, inside the root, if at all they are different, they are the same, but they have the same order, like the examples that we have. Then we have surd. We open the bracket, a plus or minus b. It is not the same as surd a plus or minus surd b. It is not the same. We have an example there. I have surd 2 plus surd 3. That is now operation general 1 squared. Can be seen as surd 2. We open the bracket, surd 2 plus surd 3. Then plus surd 3, surd 2 plus surd 3. After opening up the bracket, finally we have the final answer as 5 plus 2 surd 6, because you are required to bring the right terms together. Remember, this operation we operate like the normal brackets, normal numbers. That is, we also include the like terms and unlike terms. We bring them together. Activity for today, you are required to operate those numbers. That is surd 2 minus surd 3 in bracket surd 2 plus surd 3. Then number 2, it is you open the bracket to surd 3 plus surd 7. And then surd 3 plus 4 surd 11. We close the bracket. For more information, reference get the KLB 2003 Secondary Mathematics Student Book 3, that edition. You can also contact us through the SMS, get us from the YouTube. You can also get us from the Facebook. You can also get us or Twitter us. Otherwise, stay tuned to Edim TV. Thank you.